Hello everyone, welcome to my channel. Now today we will discuss about iodoform reaction. Now what is iodoform reaction? The aldehydes and ketones having at least one methyl group linked to the carbonyl carbon atom, that is your CH3CO group, which is your methyl ketone, या acetaldehyde group, are easily oxidized by excess of I2 and aqueous alkali or dilute NaOH, or you can write sodium hypoiodide NaOI. Then a yellow precipitate is formed, which is known as your iodoform is produced, and this reaction is known as your iodoform reaction. So that means यहाँ से हमें ये पता चलता है कि which type of compounds generally undergo iodoform reactions. The compound having one methyl group which is attached directly to the carbonyl carbon atom. Okay. Now let us take one example. Suppose acetaldehyde. So this is your aldehyde carbonyl group is present here. This is your aldehyde group, and this one is your one methyl group which is directly attached to the carbon, and this hydrogen is your alpha hydrogen. So when this acetaldehyde treated with iodine, first of all it forms triiodoacetaldehyde along with hydrogen iodide. Again, next step, the triiodoacetaldehyde when treated with alkali NaOH, then it forms CHI3, that is your iodoform, and the corresponding salt of the acid, that is sodium hormate. Okay. Similarly, you can also that means we can also write the reaction directly instead of these two steps. When I will write acetaldehyde with sodium hypoiodide, then it forms iodoform plus sodium formate plus sodium hydroxide. Okay. Similarly, take another example, that is your acetone. When acetone is also a methyl ketone group CH3CO, and another member is also CH3. So when that means here into this carbonyl carbon two methyl groups are attached. Okay. Now when acetone treated with iodine in presence of alkali, first it forms, because it is acetone, it will form an intermediate triiodoacetone. Then this triiodoacetone again treated with sodium hydroxide, it forms iodoform along with sodium acetate. Okay. Now what is the difference between these two? Here, see here. Here this is your CH3 group, here is your CH3 group. Here this is aldehyde functional, that means to the carbonyl group the only hydrogen is attached. Here to the carbonyl group one CH3 group is attached. So they will differ only in the salt. When you will take hydrogen, it forms sodium formate. When you will take an alkyl group, then it forms sodium acetate. See here how it happens here. If I will show you, CI3, this is your, so it will form CHI3, that is your iodoform, and this is your HCOONA, that is your sodium formate. Okay, this is your sodium formate. Okay, similarly here also you can take this one H. Okay, this is your iodoform, and this is your sodium acetate, that is CH3COONA. This is your sodium acetate. Here also, if you want, you can write the reaction directly instead of these two steps. Acetone when treated with sodium hypoiodide, then it forms sodium acetate plus iodoform plus sodium hydroxide. Okay, this is the process. How will you remember the product? But there is the mechanism. Actually, there is mechanism for this reaction, and we will discuss the mechanism. Okay. Now let us discuss the mechanism of the iodoform reaction. See here. Suppose one aldehyde and take C double bond O CH. If I will write one aldehyde or one ketone, if I will put R equals to H, then it becomes aldehyde. If I will put R equals to any alkyl group, it will convert it into ketone. Okay. So suppose you also know that always the methyl ketone group will undergo the iodoform reaction. So we have to write one methyl group directly attached to the carbonyl group. Okay. So if I write the methyl group CH2H, is it correct or not? Yes, it is a CH3 group, methyl group directly attached to carbonyl group. Okay. Now what happens here? The alkali which is present here, that is your NaOH, which gives rise to Na plus OH minus. Okay. That alkali that will take a proton here. That is, it will move water molecule. Now this bond goes to this position, and here this shifts the position. Okay. Now what will be the reaction? Okay, see here, R C single bond O minus. Here it is what? Double bond CH2. Okay. Now to this we know that there is addition of iodine molecule takes place. Okay. Now if I add one iodine molecule here plus I2, that is II. Okay. And if this reaction, see here, if this bond goes to this position and this goes to this position bond, this becomes shifted to this. Okay. Now see here, what is the product? Product becomes R C double bond O single bond CH2 single bond I. Okay. Plus I minus. Right. Now see here to this ion, if I will treat one iodine molecule, then I will get one monoiodo compound. Similarly, if I will treat in total in this iodoform reaction, we have to add 3 I2 molecules. Okay. So this is one I2 molecule. Again we will add another 2 I2 molecule. And if the step continues, okay, if the step continues, again if I will repeat this step again and again 2 times, then what will the product? The product becomes R C double bond O C. See here, if I will add another I2 molecule, again one hydrogen is removed by substituting one iodine, and again if I will add the third I2 molecule, again another hydrogen, the last hydrogen is also removed by adding one iodine molecule. So in total all the alpha hydrogen atoms are removed by substituting the iodine molecule. So what will be the product here? You will get a triiodo product. Okay, this is a triiodo product. Okay. Now in this step, in this triiodo product, what happens? Again one alkali, one nucleophile will again attack to this position, attack the carbon in carbon. Okay. And this goes to this position because carbon becomes pentavalent. Now what will be the product? You will get R C single bond O minus single bond OH. This is your what? This is your CI3 molecule. If I will write CI3. Okay. Now in the next step, further what happens? This goes to this position and this is removed. Okay. If it will removed, what will the product you will get? What is the product you will get? R C, this is your double bond OOH, that is your one acid, plus another one is your CI3 minus. Okay. Now in this step, what happens here? This acid molecule releases one H plus ion. That H plus ion will added with the CI3. Okay. There is a bond break. Here there is a bond, right? So there is a bond break takes place. This becomes O minus and this treated with this. So what will the final product you will get? You will get the product is CHI3. Okay. That is your resulting product. Iodoform. This is your iodoform. That is your yellow precipitate, and the salt is your RCOO minus, which further on reaction with Na plus forms your RCOO Na. Okay. Now see here, if here what happens, instead of R, for example, if I will put R equals to H, what will be the compound? The compound becomes CH3C double bond OH. If R is equals to H, then the reactant is your acetaldehyde CH3C double bond OH. That means if the reactant is acetaldehyde, what will be the product you will get? See here, what will be the product you will get? If R is equals to H here, then in the product also, one is your iodoform, that is always constant, and in this case you will get what? You will get HCOONA. That already we have discussed. If we will take acetaldehyde, then the corresponding salt is your sodium formate. Instead of R, it is HCOONA. And if we will take, instead of R, H, if we will take CH3, Then what is the reactant? The reactant is CH3, C double bond O CH3. That is your what? acetone. If it is acetone, then instead of R, again we will put what here? CH3. So it becomes CH3COON, that is sodium acetate. That also, that example also we have already discussed. Okay. Now this is all about the mechanism of the iodoform reaction. Now let us discuss some examples related to iodoform reaction. Now see here. First of all, this one is what? This is your pentane 2O1. Okay, pentane 2O1. So in this case, 1, 2, 3, 4, 5 position is a keto functional group. Now see here. First of all, either this reaction will give the iodoform reaction or not. First we will see that. We know that those compounds which are directly having methyl ketonic group or directly attached to the methyl group to the carbonyl group, that will undergo iodoform reaction. Here what happens, this methyl group is directly attached to this carbonyl group. That is why this will give the iodoform reaction. If it will give the iodoform reaction, how will you know the product without doing the mechanism? So here what happens, you just remember one thing. To know the product, you just break here. This is for to know the product only. Okay, you just break here, and you know that one carbon atom, the methyl group, that will form the iodoform reaction, or that will form the iodoform compound. So one compound you will know, you will get is iodoform CHI3, and the rest compound which is there, you have to add one. You have to add one corresponding salt ONA. Okay, so that will form the corresponding salt of the acid. So the compound is your CH3, CH2, CH2, COONA. Okay, so this is your what? Actually this is the sodium salt of butanoate, sodium butanoate, and one is your iodoform compound. This is your iodoform. Okay, so this will give the iodoform reaction test or iodoform test. Now what is about pentane 3O1? Pentane 3O1, see here, 1, 2, 3, 4, 5. Here this one is your carbonyl group. To this carbonyl group, there is attachment of ethyl group in both sides. There is no methyl group directly attached to the carbonyl group. That means this is the compound which doesn't satisfy the iodoform reaction condition. So it will not give iodoform reaction. No precipitate is formed. No precipitate is formed. That means it will not give iodoform reaction. So if there is some questions like this, you distinguish between formaldehyde and acetaldehyde. And what is the IPSC name of this compound? If I'll write methanol, because there is one carbon atom, and here this is ethanol. Ethanol. Now tell me, which of these two compounds will give iodoform reaction? See here, this is a compound where to this carbonyl group, that means to aldehyde, there is no methyl group, but here to this carbonyl group there is attachment of methyl group. That means this is a methyl ketone group, but this is not a methyl ketone group. So acetaldehyde or ethanol, this is your acetaldehyde, the common name is acetaldehyde, and here this common name is formaldehyde. So acetaldehyde will give the iodoform reaction test, and formaldehyde will not give the iodoform reaction test. Similarly, distinguish between acetophenone. The name of the compound is acetophenone. Phenyl group is there, methyl group is there, so acetophenone. And what is the name of this compound? This is your benzophenone. Benzophenone. So tell me, which of these two compounds will give iodoform reaction? See here. Here there is a methyl group which is directly, this is a methyl group directly attached to the carbonyl group, that means it will give the iodoform reaction. But here to this carbonyl group only two phenyl groups are attached. There is no methyl group is directly attached to this. That means this will not give the iodoform reaction test. Okay. And next is, this one is your benzaldehyde. And this is your what? This is your acetophenone. Same thing, we know that acetophenone will give the iodoform reaction, but in benzaldehyde the phenyl group is directly attached to the carbonyl group. There is no methyl group is attached, so it will not give the iodoform reaction test. Similarly, another one is acetaldehyde. acetaldehyde or ethanol, and this one is your what? 1, 2, 3 propionaldehyde or propanol. 1, 2, 3, that is propanol. So tell me which of the following two, which one will give the iodoform reaction? See, this one is the acetaldehyde directly attached to the carbonyl group, so this will give the iodoform reaction, and this will, there is only ethyl group, no methyl group is attached to the carbonyl carbon, so it will not give the iodoform reaction. Okay, so if the question arises like this, distinguish between these two compound, any of the two compounds, you will easily know which one will give the iodoform reaction and which will not give the iodoform reaction. Okay, now another important point is there, except your methyl ketone group, there are some alcohols which also gives iodoform reactions. Only one alcohol, that is ethyl alcohol, 𝗶𝗰𝗁𝐻2H5OH or ethanol, and one secondary alcohol, that is your CH3CHOH, this type of group, this is your secondary carbon. They can easily converted by oxidation, will be converted into ethyl alcohol, will convert into acetaldehyde, and the secondary alcohol will convert it into the corresponding ketone, methyl ketone. Okay, that is why they will give the iodoform test. So see here, if if there is some questions arises, distinguish between ethyl alcohol and methyl alcohol. See here, we know that already I have told you, only one alcohol, that is ethyl alcohol, on oxidation gives acetaldehyde. Okay, that is why only ethyl alcohol will give iodoform test, no other alcohol will give iodoform test. That means here ethyl alcohol will give the iodoform test, ethyl alcohol, only one alcohol, but methyl alcohol will not give the iodoform test. This is one distinction point. Similarly, if you compare between ethyl alcohol and propyl alcohol, see here, ethyl alcohol, because on oxidation it will give acetaldehyde, that means it gives iodoform test, but propyl alcohol will not give the iodoform test because it will not give the methyl ketone group, right? The carbonyl group is not directly attached to the methyl group. If you oxidize this compound, it will give a propionaldehyde compound, and we know that propionaldehyde is CH3CH2CHO, and this will not give the iodoform reaction test. Similarly, another point is a secondary alcohol. See here, this one is your secondary alcohol, which is an isopropyl alcohol. The name of the compound is isopropyl alcohol. So isopropyl alcohol, any secondary alcohol on oxidation gives a ketone, and isopropyl alcohol, if you oxidize it, it will give ketone CH3, that is your acetone, CH3 C double bond O CH3. This is your acetone, or one type of methyl ketone. See here. So to this carbonyl group, methyl group is directly attached, that means it will give iodoform reaction, it will give. So any type of secondary alcohol group, that will give the methyl ketone group, that will give the iodoform reaction. But here what happens in the propyl alcohol, this, if you propyl alcohol will oxidize, it will give propionaldehyde, and that will not give the iodoform test. So this is also an important point you have to remember, except your aldehyde and methyl ketone group, alcohol in secondary alcohol, all types of secondary alcohols, this type of group if present, they will give the iodoform test, and only one alcohol, that is ethyl alcohol, will give the iodoform test. Okay, now let us discuss some examples, okay, based on iodoform reaction. See here, this is one acetaldehyde and this is one phenyl acetaldehyde. So in between acetaldehyde and phenyl acetaldehyde, okay, in between these two, this can be distinguished chemically by this type of reaction. See here, in acetaldehyde, there is a methyl group directly attached to the carbonyl carbon, but here there is no methyl group is attached to the carbonyl carbon. So that means these are the two compounds which can be distinguished chemically by the iodoform test. Okay, next is another compound, compound A, having molecular formula C8H10O. This is a NEET 2018 question. C8H10O is found to react with sodium hypoiodide NaOI produced by reacting Y with NaOH and yields a yellow precipitate which characteristic smell A and Y respectively. That means the compound, we have to identify the compound A and Y. Okay, first of all C8 we have to choose. In this compound the carbon number 8, in which case you have to find out the carbon number 8 along with hydrogen 10 and 1 oxygen is there. So you have to, first of all we will see which of the options will satisfy to this compound. Okay, now and another one important point is, if this will undergo, this is the reaction of iodoform reaction, and which option satisfies the iodoform reaction. First we will see that. See here, here there is a alcohol group, this will not give the iodoform reaction. Okay, here this one is also the alcohol, that will not also not give the iodoform reaction, because we know that only one alcohol, that is ethyl alcohol, will give the iodoform reaction. Okay, so these are the two options which are rejected. Now next is, here also there is a alcohol, that will also not give the corresponding that means your iodoform reaction. But here there is a options, see here, where there is a secondary carbon is present. We know that every secondary alcohol will, on oxidation, they will give the corresponding ketone, and one methyl ketone group is also there. If we will oxidize this will give a ketone group. Here there is a ketone group. Okay, so C double bond O ketone group is directly attached to the methyl group, that means it will give the iodoform test. Okay, so the corresponding options is A is this and Y is this. So this is the right answer. Next is, see here, which of the following does not give iodoform reaction? Does not give, see the question, does not give. Okay, now this one is your pH, phenyl acetophenone group, PHCOCH. Actually the option is PHCOCH3. Okay, this is the C option. Okay, so acetophenone, yes, carbonyl group is directly attached to the methyl group, so this will give. Okay, this will give. And here what happens, here methyl alcohol is there, methyl alcohol will not give the iodoform reaction, we know that. At acetaldehyde will also give the iodoform reaction, and here propyl alcohol will also not give the iodoform reaction. So here does not give iodoform reaction test means two options are there, one is A and another is B. So the answer for this is option A as well as option B. Two correct answers are there. Okay, now next we will discuss about the another reaction, this reaction. See here, in this case C double bond O means this is a carbonyl group which is directly attached to the methyl group, that means methyl ketone group, so it will undergo the iodoform reaction. If it will undergo the iodoform reaction, then what will be the product? The product becomes CH3C. okay, see here, and here this is also same. Okay, there is no change here, only the double bond you have to break here. Okay, you have to break here. Okay, and already the methyl group will form what? That will form the corresponding iodoform CHI3, and this part will form, you have to add on ONA here, already we have discussed that. This becomes here COONA. Okay, so this is your iodoform and this is the corresponding. Now let us discuss another question, that is, which is the most suitable reagent for the following conversion? Now see here, this is a what type of functional group present here? Keto functional group and alkene double bond. Now it is converted into, the double bond is as it is, only there is a change occurs in keto will convert into corresponding acid. Which of the following will convert it to this? We know that tolerance reagent is, that means it is not a proper, it is a mild oxidizing agent that will not convert keto into acidic group. Benzoyl peroxide will not, TN and NOH also not, and iodoform reaction. Yes, we know that this is the right answer, because we know that when there is a iodoform reaction, if you treat this compound with iodine I2 and NaOH, then there is a cleavage takes place here, and this part becomes converted into our iodoform. We know that will form the iodoform, and this will give the corresponding acid. and this is the corresponding acid 𝗔𝗹𝗱𝗃. If we treat this with the salt, the corresponding salt will be formed. Okay, so right answer is this one.